Last time I showed you how you can create output for a user using code that you don't write yourself, but that you just borrow, so to speak. And we do that by first declaring our intention to use some other code by using the using keyword, and then we specify where the code can be found, what the general title of the code is. And the one we need is system. Very, very basic library of code that you have by default, kind of. And the code we want to use now was related to the console, which is our primary input-output method right now. And console, the class, has a static method write, and it has a static method ReadLine that we're going to use. And we can run this code. Like this, good enough. And we can generate output. Oop, that's not what I wanted. This one. Very simple, but very effective. You're never gonna get rid of this console.WriteLine. It's a command that you're gonna use for the rest of your career in certain circumstances. It's just way too useful. When debugging, for example. Not ideal, but very, very useful sometimes. On the flip side, we've also seen input before, which came in this form. Our main method allows for a string array as input, and this is translated from the command line arguments you provide to your program using your operating system. And when the operating system starts your your program, it will use the command line arguments you provided as strings that get passed onto the main method, as if it was a normal method and we just called it using a string array. Sometimes, however, you don't want to define some input and just let the program run, which is a bit ironic, you'll see later. You want to react to something the program is doing and then provide new input during runtime, depending on what the program is telling you. And just as we have this command that lets you quite easily output something to the console as output to the user, we have a counterpart to this that lets us read something from the console. And because it's the counterpart, it's quite easily rewritten like this. It's ReadLine instead of WriteLine. The exact opposite. We're not putting a string out to the console, we are reading a string in from the console. The way that would look when you run your program is that the terminal or the console window you have open will simply allow you to type something. Just with a keyboard, just type something, and at a certain point, once you hit a certain input, the system will think you've done everything. Everything you've typed in is now gonna be put into one single string and passed on to your program. That's what ReadLine does. The moment we hit ReadLine, the program will wait. We will get stuck in this method call until we provided all the characters, all the text this method expects. If I just run this now, we will run into this little issue, because after 5 seconds, about 5 seconds, we had a timeout because it's a browser-based system right now, not a fully interactive one, where this program is running in the background, so to speak, where I don't really have access anymore. And so I never get to input something, and after 5 seconds, the process is just terminated by default. In a real console, it would just wait indefinitely until you kill the program yourself. To get around this, for this browser-based system, we have this, the input. And that's where the irony came from. I can define the regular runtime inputs that I would get when running this command before I start the program. It's a bit weird. It's not really reflective of the real-time input that you would have in a full system. I'm pretty sure there are implementations for online compilers that do allow you to make real-time input. This one just doesn't. It's good enough to get some practice with learning the commands, though at some point you're gonna switch to full-on development on your own machine anyway, and at that point, well, this is a non-issue. But just an example, I'm just gonna provide some text. And you can just write full-on sentences, several lines, whatever I want. And I provide some text as input. And now when we hit a read line, for example, read line, it's not the only one. A command that expects input from the terminal or console, then it will simply extract the text from here, as if we typed it in right when we called this method. So I can run this program, and it will read that input, and this command is satisfied, and we'll continue down here at this bracket, and the program is over. That's not intended. Let's try this. What happened? Oh, caps lock. String input equals readLine. ReadLine reads text. So, no surprise here. We're gonna store the result we get back into a string. And then we're gonna output that. Maybe make that a bit differently. Input was like that. Remember, strings can be combined by using addition. Plus for two integers is defined as make a mathematical calculation. Same with doubles, longs and whatnot. But for strings, an addition is defined as just take the left string and the right string and squish them together into one single string. If I run this, that's what I get. If I change the input, we get some other output here. So without changing the program, I can create different output and potentially different behavior. Convenient. Let's try to make this a bit more interesting. To write a program that expects you to input something. So a classic first program. String age equals line like this. And then we can say plus name plus age plus like this. I will get 2 inputs. The program would first write something to the terminal, providing you instructions on what to do. Then it expects input and will wait for your input. Once it has that input, it will ask again for new input, writing something to the terminal, telling you what to do, then waits for your input, and then will output everything else, and the program is finished. Since we have now 2 different inputs, we should ask the question, what exactly is the condition for ReadLine to be satisfied? When does ReadLine consider your input completed? If I run this just as is, what's going on? Did I make a typo? Oh yeah, here, forgot the semicolon. Alright, nice lesson to learn. The compiler errors aren't always the most obvious ones. It's complaining about string in this line, but that's completely fine. This line isn't wrong, it's this line. This is what the compiler sees. So that doesn't make sense. You might expect something like this, a dot operator, but certainly not the keyword string. Semicolon is missing. So if I do it now, we get some better input or output. Something you can see, if this was in your console, the text you type in would usually be readable. So you might have, as an example, the console or terminal would show this, and since we have a right line, this is where the cursor would be, and then I could type in a name, and then your age, and then 1000, and then you would have so this could be, for example, the input you see in a terminal. We don't get that since our input is separated from the output. But we'll get to revisit this once we switch to on-machine development, away from the browser. Let's try this again. And have a look at the output itself. You are some other text. Alright, that lines up with some other text. And then our... well, this is empty. Those are 2 spaces with nothing in between, as far as we can tell. Where did the input come from? We didn't type anything in, we only have some other text. Maybe make this text a bit longer. Let's see what happens. Didn't change anything. Weird. Maybe let's split this up into 2 lines. Ah, now we get something. Now age is considered to be separate from some other text. And if you look here, you notice that we have some extra space that we read. Look here, there's some extra space after text. Remove that, things are clear again. So this first read line seems to read in some other text. The second read line seems to read in this abomination. What is the distinguishing factor between these 2? It is this Newline character. The one you don't really see usually, except you see the shape of your text. It's on a new line. What you don't see is that making a new line is a regular character. It's a Unicode character, it's a control character specifically. It's one of the type of characters you don't see visually. They're more to inform a system that something needs to happen to reshape how the rest of the text looks. So in a way, it still determines the look of a text, but only by changing the look of the other characters. There are many variations of this, and not every control character is directly responsible for reshaping the look of the text, but Newline is kind of. And the Newline character is what you type when you hit enter. The enter key on your keyboard is, just like any other key, writing a character to the input. It's just not a letter that you're used to, it's the Newline character. Or characters plural. There's actually a difference between different operating systems, what the default Newline character is, and different libraries will interpret this slightly differently. It's usually an operating system difference. There's... okay, this goes... let's go make a little history check. The way our keyboard and input operates is more or less directly lifted from typewriters, or the systems we use for typewriters. And the enter key on a typewriter was just the Newline key. It's just a key that would physically shift the paper in your typewriter by one line, so you can type the next line. But just going to the end of the text and then going down, well, that leaves your writing position right here at the end of the line, or the previous line, but I want to write here at the front. So for the typewriter, you also have a carriage return, which means instead of just going down to the next line, instead of just, well, you're not going down, depends on what typewriter you're using. Usually the typewriters we used to would just shift the paper up a bit by one row. Different topic. And then you would have a carriage return. The carriage is the thing that moves the paper. Again, different typewriters work differently, but most of the time the thing that writes, which would be equivalent to our cursor, that little blinking thing here, would be fixed position on your typewriter, and the paper would be placed in a drum, and this drum would move back and forth and rotate around to move the paper. So you hit enter, you move to the next line, you hit carriage return, which will move the entire drum with the paper as far to the right as possible, so that the writing head, our cursor, would be placed at the left side of the paper. And that's for the typewriter you might think of. The English-speaking world has used that. Other typewriters exist for different writing systems, but they will have similar rules for their systems. My point is that to go to the next line like this, from this one, first line on the far right, second line on the far left, is actually two commands. It's switching to the next line and switching to the start of the line. We move along 2 dimensions here, and that's 2 inputs, 2 separate inputs. At least on Windows that's the case. Windows uses a Newline character and a carriage return character, the way you would do it on a typewriter. If you're on a Unix system, you can skip the carriage return. It's a Newline, and Newline character is understood as, yeah, we're gonna start on the new line. It's gonna be on the far left or on the far right, depending on what language you're using, but it's clear where you're gonna go. Why bother with a second character for that? It's all in one. Can be confusing. It's something you might need to look out for if you're working with a library that works on multiple operating systems. but there are libraries that deal with that. For example, our ReadLine command here writes some text and then skips to a new line. And this ReadLine command itself will check what operating system you're on, and depending on that will either use the 2-character version for Windows or the single character version for Linux or Unix in general. I think it's universal to all Unix. I think Mac had at some point in the past, decades ago, another 2-character version, like the reverse order. Like you can have carriage return, so first go to the left and then go down, or you can go down and then to the left, so carriage return, new line, or new line, carriage return. I think they had that different from Windows, but not anymore. I think nowadays they do it like Unix. I'm not too sure, I don't do development for Mac OS or Apple systems in general. Anyway, some libraries deal with that. ReadLine itself also deals with that. And that's important because ReadLine actually looks out for this Newline character. Well, Newline characters, plural. When you input something in the terminal to pass on to your program, you type in whatever you want. But the moment you hit enter, you pass on the Newline character. And that's a signal for ReadLine that you're done, because you're adding the new line character. Your line is done, you're going to the next line. So everything you've written so far is assumed to be the input that you want to store in the return value. So what I do in here is the same thing. I'm writing text, and at this point I'm hitting the new line character. So up to this new line character, everything is put into this string name. And this next read line will take this input until, in this case, not the next new line character. The online system will assume just you have a new line at the end of this, and that's where you end everything. So essentially this online compiler will automatically add a new line after your text, if you didn't place one yourself. That also means you can have empty text, of course. You didn't input anything in here, you just immediately hit the new line character, so you have an empty string, but that's still valid. Let's say I don't want to just work with strings. I mean, this is a nice little party trick, I guess. Well, maybe not. Depends on which decade we're throwing the party. I bet if you were on the 70s and you were showing someone, hey, I have a computer and I can make it output your name, that would be impressive. Nowadays, well, cool, I guess. We had a little demonstration for a somewhat useful program. A while back. Let's see. I want to output the result of A plus B. And I can do that with first converting A to a string, and we learned about that using another pre-existing code to string, which turns A into a string. And I can combine a string with another string, with an add, with a plus sign. And then I can do P to string. And do this. And now I want to add A plus B. this will not quite work the way you expect it to. And that's just this little sidetrack. 1 plus 2 is 12. How come? The plus sign is used for combining two strings into one string, which works just fine up to this point. But it can also be used to combine other types with a string. I don't need this to string here. I can leave it like this, and the output will stay the same. If you add any data type with a string, the compiler will assume you mean this. You use the toString method, which every type has. I mentioned that last time. And then combine the two strings you get. One from the toString and the other you already provided. And since addition is used everywhere here, we start on the far left. We use the toString internally to generate a string version of A, combine that with plus, the character, to get 1 plus, the text. So this results in a string, and then we have a string plus an integer, B. So we combine string with another type, so we use toString on this other thing, the B, generate a string 2, and then combine it with the first string we get. Our 1 plus is combined with 2 to 1 plus 2. Then we combine that string with an equal sign. We get 1 plus 2 equals. And then all of that is just a string. 1 plus 2 equals just a string, which is combined with an add with A. And that string is then combined with B. We need to change the order a bit using brackets to make sure that this is happening before all of this. A and B are just integers, so the plus in here, if it's just these two, will be an addition, mathematical addition. And then we start on the left here, combine all the different values and strings into one large string, which is then combined with the integer that we get as a result of this addition. That's how we get 3. So that's something you have to look out for when you work with strings. But it's also quite convenient because I don't have to write toString everywhere. That's pros and cons everywhere. And now I want this input to not be hard-coded, but based on whatever I pass onto program, or to our program. The last time I demonstrated this, I used args and derived values from the command arguments. I want to do this now while the program is running. I want to read input that the user provides after they started the program. Alright, so console.line, or maybe console.ReadLine. Provides a value for A. And then we do readline. And then we get string value for A. And then we can copy that and do the same for B. And now we have to convert this into an integer. No problem, we know how to do that. We can use another predefined method. We use int.parse, which is int32.parse, that class, but we can shortcut it to int, more convenient to write out, and value for A. And for B, we use int.parse value for B. No problem. And now we get some output. Use 1 and 2. And yeah, once more, because it's separated, we don't see it, but if you have this in a console, you would have... It would move more like this. This is what the terminal would show you in a real-life scenario. This online compiler separates the input and output so you don't see it in one go. But that works, and I can run the same program with other values, and it generates new output. Great. What happens now? We get exceptions. I've shown them briefly because they are a kind of error message you need to be able to understand. Exceptions are exceptional situations. In this case, the situation is that we try to parse the word 10 into an integer. And in theory, you could write a program that can use written numbers, as in completely written out, and translate that into real natural numbers to store on the computer. But this parse method doesn't do that. It expects you to have a sequence of characters that represent numerals. So it can't do its job. We gave it the wrong input, it doesn't know how to handle this, so we get an exception. This is an exceptional circumstance. We don't know what to do. How do we get around this? Well, we did learn about a different parsing method that doesn't have this issue. That was the try parse. Here for A. And it will have out int A. And skip this. And this will give us a Boolean value. So we can do if this did not succeed. Looks a bit more complicated, but you'll have to get used to this style of programming sooner or later. We have a method call inside an if with a negation in front. So if it did not successfully convert, try to parse plus value for A to int using 0. Like this. And then run the program again. We dealt with the error. Maybe not in the best way, but at least the program didn't crash. It still fulfilled its duty, it completed to the end, and we get a nice little output ourselves. We had some error handling deal with the error that came up. The most annoying part about error handling is not the catching an error. It's deciding what to do in case of an error. Like right now, I simply use the default value for A, try parse, as most try methods will either give us a value, that's the result of the operation, or it will give us the default for that variable, and the default value for an integer is 0. And 0 is a valid value to use for the rest of the operation. I mean, I can just input 0 intentionally, just fine. But using 0 as a default value might not be what you want. Maybe you don't want to waste time on running the rest of the program if it's 0 anyway. So you might decide to end the program early. And we can do that because this is just a method. And we can abort any method by just calling return. Like this. Of course, we have to count that B might also be wrong. So we have to do the same thing for B as well. And now we abort in 2 cases, fail to parse A. Let's do it like this. B. That looks a bit better, right? We can handle with B, we can handle A. Maybe we even want to move this up. So we read in A and immediately try to parse it, and if we can't parse it, we abort immediately and don't bother with... what am I doing wrong? What am I doing wrong? Oh, I've deleted this. Right. We don't bother with reading in B if A was already wrong. So this would be very simple error handling. We simply abort. Alternatively, you could define a default value or decide something else. It gets more complicated when this isn't the end of our program. Maybe you want to do some other stuff. Let's say I want to do this. Oops. Keyboard shortcuts. Maybe I want to do this twice. Oh yeah, right. To just reuse B and A. And my bad. You're right, compiler, my bad. Alright, so we have several inputs we want to read, and we abort the first time it doesn't work. That's no good. How to deal with that? Well, for starters, this is a lot to write out, so we should probably simplify things a bit by putting all of this into one method instead of rewriting this whole thing again and again. And well, let's do it like this. Let's public static bool request number and in output number, and then we can do all of this inside a method. Can do number here. Let's rename a few things. This number, like this, and now we could call request number instead of all of this. Not request number. Float int a. Failed to. We have to change this since we don't know the input anymore. To read number aborting. We can do that with B as well. Maybe add a comma in here. 10, 7. And then it works. It's a bit better now. We could improve this a bit more though. See, right now I'm just aborting the program, but why should I abort on the first misinput? It might be just a general error on the user side if they had a typo. Maybe you hit enter right after hitting another character and then, oops, my mistake. The entire program aborting is not the best scenario there. So, what if we didn't just try it once, but several times? We could do. I can do. Wait. Keyboard layout's changed again. That. Number. Yeah, like this file. Not. Number. Could do like this, for example. Have I? Oh, because. Oh, right. And I made more mistakes. That's what I needed to do. As you can see, I make mistakes all the time. Yeah, we can skip this as well. I didn't really think too much about the process here. And yeah, this can go as well then. Right, so this is more improvised right now, but where's number? And it's A equal. What is going on? Where's? Okay, it's typing now correctly. Weird. So, now finally it's working. As you can see, even if I make wrong inputs, it will simply request another value until it gets a valid integer value. If it's not getting a valid integer, it will simply try again. And once we get a valid integer, that's what we return. Request number is now dealing with the error by simply requesting a new value. A situation where this does not return an integer cannot happen anymore. It either will return an integer or get stuck in a permanent loop because the user never inputs something valid or never inputs anything at all. That itself could be an issue though. Let's do this. No. und max retries. Okay, this might be a bit weird to look at for the first moment, but you recognize this as itself. That's the decrement operator, the post decrement operation. So we read the value for max retries and then decrement it by 1. And the result of this is just the value, the current first value of max retries, which is then compared to 0. So it's the same as making sure that we compare max retries, but also make sure that it's decremented, instead of writing this out as 2 variables here. And then we can deal with that in a very specific way. We could actually leave this as is. I should maybe input something. So for example, I could input 0 retries. In which case, when we return, it will be the default value out from number. If I allow for 1 retry, for both of them, well, we see that this first one failed. It retried. The second retry, or the first retry, the second attempt for the first request failed. So it defaulted to number. And then it read for B, the first request with the 1 worked. Let's change this to 0. Didn't change much. Now we have first try for A, failed, so we get a 0. First try for B, failed, it tries again. Second try for B, worked, we get a number 1. The thing is, we have now a guarantee that this method will at some point return. But now we are back at the beginning with default value 0. That's not acceptable for us right now. That doesn't make too much sense. We want to limit how many retries a user can make. But we don't want to deal with this forever. Now if max retries is less than 0, that means we used up all our retries. Yeah, that works. And we can used defaulting to 0. See, like that, we can give us some feedback that it happened. That's better, at least. We get the feedback that we defaulted to 0. But I don't want it to use this scenario. And now imagine that you are responsible for writing this code. Not this entire program, but you're part of a team and your responsibility is just this one method. You have no control what happens outside. And you now have to make sure that whoever uses your method will have, for one, a way to control how long it can run. At least if we ignore that ReadLine can, in theory, get stuck forever if there's no input. And we want to make sure that whatever value we return is the correct input value a user decided on. That's important. We don't allow for a default of 0. We could restructure our method to the previous model where we try to get a number and we return a boolean that tells whoever calls us whether or not it worked. But maybe this method has already been used everywhere in someone else's code. Maybe you're just maintaining it. Maybe someone else wrote this method. It has been integrated to the program in many different parts, and you're just cleaning up a few things internally, but this method signature, it's stuck now. You can't change it anymore. What do you do? Do we have any way to provide the caller of our method the information that it doesn't work? That we failed to get the input? All max retries is an integer value, a value type, so we get a copy of the original value, but we can't use anything with max retries that would send the caller information back. This is not an out or ref variable, it's not a reference type. This is not a communication method for us to tell the caller something. We have the integer that we return, but any integer we return might be a legitimate value that the user has input. So we can just say int max value or int min value, for example, is invalid. And that's it, because someone might input those specific values. So we don't have any method of telling the caller something went wrong, please do not use this value, escalate this error situation, and deal with it. We are not in a position in that scenario where we can escalate, we can tell the caller what to do and how to behave. We don't have access to that code, potentially. We're just one small member of a larger team that has responsibility for maintaining everything. And for that kind of scenario, there's a separate, call it channel, that can send back information to whoever called us. It's a channel we haven't accessed intentionally so far. But we have seen it happen all the time. Well, not all the time, but we have seen it happen a few times now. One time earlier. When you get a situation like this, where your method is out of options and you can't do anything anymore, and you have to somehow let someone else know, I ran into a situation I cannot handle, I don't know what to do anymore. I cannot fulfill my original function. You can yourself throw an error. You can throw an exception. You declare an exceptional situation. Just as we had earlier, the case with int.parse, which will throw an exception if it cannot parse the input. We can ourselves decide to throw an exception and declare that our method was unable to fulfill its duties. We cannot handle the situation at hand. Please someone else deal with it and decide what to do from here. And we can do that, of course, down here. After making that output, use up our retries, default into 0. We can decide we want to access this other channel for giving feedback. We want to throw an exception, which is literally done with the keyword throw. It's reserved for exceptions. It's a keyword, we throw an exception, our method declares, here, I got an issue, you deal with that. I'm done. Not my responsibility anymore. And throw is similar to return. It's a keyword that expects you now to provide something to throw back. And since we're throwing exceptions, we need to throw an exception. what is an exception? Exception is, for one, just the term in general that there has been an exception at the program. There has been a situation that is unusual or unexpected. We didn't anticipate this, we haven't had the chance to implement code to deal with that. Yeah, we don't know what to do. Program is panicking. But more specifically, exception is the name of a class. Just like console, it's a class you have access to by default, because it's a very important part of the language. And in the simplest case, we can simply create a new instance of an exception of this class and throw that back. So we have a class that we create an instance of. So of course we use the new keyword and create a new exception. Something like that. We could do this another way, of course. Exception e equals exception, and then throw e. So just like return. Only throw is limited to exceptions. Whereas return would be for all kinds of return values. Also, this will, just like return, abort your method. The moment you hit a throw, it's done. No, not technically, not really, but we'll get to that in a minute. Throw doesn't deal with the normal return. Doesn't return with a value that's just used as the result of this method call. It is using a separate channel in the language, and this exception will now pop up in this request. And actually we can already run this. You can see provide a value and used up, forgot the D, used up all retries defaulting to 0, also not valid anymore, of course. But you also see unheld exception. We threw an exception. Exception of type blah 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 was thrown. And it was thrown in request number. We can make this a bit nicer if we take this text. Instead of outputting that in the console, we put that into the exception constructor, because it has other constructor calls. We can call that with just empty constructor, the default constructor. But usually we want to provide some more information. So we put some text in here. And we ignore the defaulting because we're not actually defaulting. And we run it again. We don't have the output up here, but we do see the text down here. Want to read the comparison again without text? Exception was thrown. Just general information that exception was thrown. But if we provide the information ourselves, it's written in here. We know we hit request number. Somewhere in there an exception was thrown, and the information the exception provided us is that we used up all retries. And usually you wouldn't bother with storing that unless you had some specific intentions for that exception, but you would just use throw new exception. That's the most common way to do it. The most direct, shortest way to do. And we can, since it's a one-liner anyway, drop this as well. And now our method that was set in stone, at least as far as the usage was concerned, has a method of handling this situation where it didn't read a proper valid value. By not dealing with it at all. We throw an exception, we throw in the towel. We decide, nope, can't do it, we don't know what to do, someone else deal with it. Whoever requested number from us, you deal with it now. And so we are right back at the start with int.parse. An input couldn't be parsed. In this case, several inputs couldn't be parsed, potentially. At least if we do this. What do we do now? We could, at this point, decide, this is a common issue we have in several parts of our program, might be worth it to switch to a different method. Just like int.parse, we also introduce a try request number that will give us a boolean that tells us whether or not it worked. But maybe we do it a different way. We do it the way that exceptions asks us to do it. Down here, we throw an exception. And it will simply shatter our entire process. But here's the thing. The keyword up here, the reason our program crashed, is unhandled exception. We throw an exception and no one deals with that. This method has thrown an exception, but okay. Well, I guess it happened. No one deals with that, no one cleans that up, so the process just crashes. Gone. Done. The operating system will simply kill it, and that's it. You can, however, handle that exception yourself. You can decide to catch the thrown exception. Request number will throw the exception. Actually, let's put it like this. And no, that's fine. Let's do it. Request number will throw an exception, and we, the caller, will decide to catch that exception. And that works using a special syntax, which is not too dissimilar from our do while. We start with a try, which is a keyword. So instead of making a try request number, we try request number. If that, I just think that's neat. Coincidence. So we still introduce the try, but in form of the try block. We use a keyword try, and that's followed by a code block. Just a regular code block like anything else, just like we have down here. And now, whatever happens in here, we will try to do it. But if it failed, if it had an exception, if somewhere in there an exception was thrown, we don't simply break our program, we catch it. We catch the exception that was thrown. And catch, well, this is not quite like our do while anymore, is another code block in of itself. But this is all we need to do for that. Now, since we defined the integer a inside the code block here, because of scope, we won't have access to it down here anymore, so I'm declaring it up above and just filling it in here. And in case we catch, we can simply line fail to read input aborting and return. So we've come full circle. We still have a try method, so to speak, but we try our normal method that throws an exception if something goes wrong. And if that happens, if it's thrown, we catch the exception before it can break our program and handle it ourselves. That's how can catch exceptions. We could do the same with an int parse. If inside this try we have an int parse, that gets a value that doesn't exist, well, no problem. We don't see any error messages down here because we dealt with it internally. This will cause an exception, but we catch this exception and then do our own little code to determine what to do next. Essentially, whatever method you have, you can automatically turn this into a try variation without rewriting the original method by simply putting it in a try block. And to every try block, you need a counterpart that decides some additional stuff. You can't just have try by itself. And for the most part, it's just the catch that decides what happens when the exception is thrown. Now, if there is no exception, if this just works, then there is no exception to catch, and this doesn't happen. That means we end up at this case again with the underhanded exception for this second request number. So that too we would put in a try block. Like that. Failed to read input. Let's copy that out. Oh yeah, and same as with A, it's inside the code block, I have to declare it outside. That's better. So we come full circle, we're at this point again. But this time the exception happens at our own terms. And we have some internal handling for misinputs. So maybe we accept. That's 2. We have 3 tries to input something. 1 first try and 2 additional retries. And with that, we don't have an issue anymore. And if that really didn't work, well, we simply abort. Now, something that might be interesting to you as someone who writes a program that aborts in a case like this is what happened though? If request number failed by throwing an exception, we might want to have the information of why exactly it failed. Right now, we understand it's this reason. There's only one case it throws an exception, right? So we already know when it throws an exception up here, we know what happened, we know why it happened. Let's add something else. Input.length less than 1. We won't allow empty input. So probably doesn't look too different right now, but let's do it like this. Well, the moment we hit this line, it will cause the input to be empty. There is no input for the second input we did. And this might have a significance for the user. Maybe it's meant as a, oh, sorry, I want to abort, this is not correct. Just hit enter without any input as a sign of stop the current process. Don't fail anything, just cancel, close, whatever. And now we have 2 separate exceptions that can happen. Either it happened here, because we have an empty input, or it happened down here because We tried to input something but failed. The output looks always the same. We don't see that as the programmers or the users. We have no idea what happened. So, when we catch the exception, we'll now not only catch the exception in general and just deal with it on our own, we'll use the exception that we caught. And to do that, we can add brackets in here and declare a variable to put the exception in. Try to execute this code, and when this code throws an exception, don't fail it, we're inside a try block, instead catch the exception. And in this case, don't just catch it, once you catch it, store it in this variable e that we provide. Like, whatever you caught, put that into our e. And in here, we can do this. Just like we do down here, we can just enter the exception e, the object, the instance, into our string, and it will just call to string for us. We don't have to do that specifically. Actually, let's not do that in here. Let's put that in the end. That'll look cleaner. So now our first request can fail in two different ways that we know of. And depending on the exact reason, we'll have a different output now. We still get the exception, but you notice we don't have the unhandled exception, because we absolutely handled the exception. User didn't input anything. Oh. Let's try the other input. You used up all retries. So now, depending on what happened, we get a different output, because we used this variable that tells us more about the exact scenario, the exact cause of the exception. At least that's the intention. That only works if the exception that is thrown contains any useful information. At the very least, we know where exactly it was caused, which is maybe important if we do again this. We can put more than one line of code in a code block, of course, and now you also want to know where did it fail. Well, we don't have an unhandled scenario. Failed to read input, sure, but the exact cause is input string was not in correct format. It happened in int parse. So catching is fine in many circumstances where it just didn't work. Who cares? Not important. Just do something else. But sometimes it's important to deal with the specific exception. At the very least, to demonstrate to a user what happened, to log it somewhere, to write it down, to let you know what is going on. Even if you want to continue running the code and not break everything. So you catch the exception and store it into your own variable, and then you can use that variable to access information about the exception. And if we do it like this, why not do that? And that. Put them both into one try. And maybe we want to advance this thing a bit. Target. Like this, and then A, and this for B. we might get the okay to change the variable. Do that here as well. Target plus target. Now, provide a value for A. Didn't work. Used up our retries on A. Maybe we add another retry and suddenly it all works for A. And then we read a value for B and that works too. Or maybe B failed. And it's all up to us to deal with the exception ourselves and to determine what comes next. Error handling is a complicated mess because there's always the question, is the error important? Can we use just a default value maybe? Do we have to deal with it ourselves? Can we deal with it ourselves? Is it a situation we don't have any say over and we should just throw an exception, as in this is very unexpected, this should not have happened? And then how do you deal with those exceptions? How detailed do you want to be about the output, and how many try blocks do you use? Do you put everything in its own try to make as many different variations for every scenario, or do you put them all together and decide if anything in this block fails, just treat it as one larger issue that's always the same? At most, block the difference so I know where exactly it happened for later for debugging, but there is no this is exactly how you do error handling. It always depends on what exactly you're trying to write. And honestly, for our little program, the pure int a so that ReadLine might already be enough. If it didn't work, okay, so the input failed to read and the program cancels, which is fine since there is nothing else anyway. But if it does work, we get our output. So, is it worth to add all the extra code for your program? Maybe. Maybe not. And that's where we're gonna stop for today. Exceptions are something we have to have a closer look in the future. Once you load some other features as well. And once we make some more complicated programs, because there's more a try-catch block can do. A lot more. But this is the simplest form. Also, throwing can be a bit more interesting. Oh right, that's something I wanted to show you. Before I completely forget, I mentioned earlier a throw is like a return. It will immediately end the method, except not really. Well, the reason is I can create a try block down here. Well, I don't want to scroll down like that. That's better. And have a catch here. What's going on? There. Ah, okay. Good enough. What happens now is if that's missing. If this exception is thrown, it will still be caught. Doesn't matter if it's happening inside a method you call or if it's thrown directly inside the try block. It will be caught. And so in this scenario, even though we have a throw, we don't immediately end the method. That's kind of the point. The reason we try this whole thing is because we don't want it to fail immediately and cause an unhandled exception or something. It's just unusual to see a throw directly inside a try. Unless you refactor some old code, that should not happen, because it seems like kind of unnecessary. You can just restructure your code to deal with that in a different way, usually. But admittedly, sometimes it's the easiest way to adjust your code or fix something. So, yeah. Throw will end the method, but only until it hits the next try block. So, yeah. Exceptions. And also console.readline as a very simple method of providing input. That's it for today. Thank you for joining in. Have a lovely Sunday, and till next time.